There are some rules we can follow to design a good aggregate. Let's check them. First rule is model true invariants in consistency boundaries. An invariant is a business rule that must always be consistent. A proper designed aggregate is one that can be modified in any way required by the business with its invariants completely consistent within a single transaction. Along with this, the rule also says that a properly designed application modifies only one aggregate instance per transaction. This is really important, so do not forget it. Let's check an example. Here, we have the application service where we define one transaction. We are modifying only the cart aggregate in this transaction. The invariant is modeled in the aggregate, as you can see it here. Rule 2 is design small aggregates. The main problem with big aggregates are scalability and performance. If you have big aggregates, you will have big objects that you will need to load in every transaction. So limit the aggregate to just the root entity and a minimal number of attributes and/or object properties. Think here on the minimum set of objects and attributes that need to be in a consistent state after an atomic transaction is completed. That should be a proper minimum. You should also check if the use cases you have are really defining invariants, or if the same use case can be achieved with multiple transactions in different moments of the time. This can help you to define better invariants and at the same time reduce the size of your aggregates. Let's check an example of this rule. Here we have a big aggregate with multiple references to other aggregates or entities, like customer or purchase order. And here we have a smaller aggregate. We are referencing only the ID of the customer instead of the entire entity, and we delete the unnecessary reference to the purchase order. The third rule is reference other aggregates by identity. If you have aggregates that are composed by other aggregates, it is better to reference those internal aggregates using the root ID instead of the entire object. When you have reference to other aggregates inside an aggregate, you could be tempted to change the state of those aggregates, which is not desired. Remember that we should try to modify only one aggregate in a single transaction. Let's check an example. Here in the cart aggregate, we have the complete reference to the customer aggregate. We can replace that and have a reference to the customer aggregate by ID using the customer ID value object. The last rule is use eventual consistency outside the boundary. There are cases where you are not going to find a simple way to avoid modifying multiple aggregates in a single transaction. If this happens, you still have a last bullet. Ask yourself and to the domain expert if they really need to have immediate consistency between the aggregates you need to modify. You will find that most of the cases it's okay for the domain expert to have the consistency eventually, maybe in minutes, hours, or even days. If the answer from the domain experts is yes, then we can solve the problem using eventual consistency. Let's check how to make this possible. Let's imagine that we have a new requirement and we need to create a card after a customer is created. This implies that we need to create two different aggregates in the same transaction. Instead of do this, we can use eventual consistency to create first the customer and eventually we create a card. To do this, first we need to create an event, like customer created. Next, we need to publish the event when the customer is created. In this scenario, we want to do it to a topic. After the event is published, we finish with the customer transaction. Now, we need to subscribe to the topic where the event is going to be sent and listen to the event customer created. And finally, we need to handle the event when it arrives. This means we need to get the event, create a new transaction, and create the card. This way we are creating the customer and the card aggregates in two different transactions. If you can follow those rules, you will have a good aggregate. But there are times where following the rules is not possible. Let's check some good reasons to break them. The first good reason is user interface convenience. Think here in a use case where an user needs to create multiple aggregates in the same UI with only one click. Here you will need to use multiple aggregates and modify them in the same transaction. The second good reason is the lack of technical mechanisms. If we want to achieve eventual consistency, we need some specific technologies, like messaging frameworks or timers or batch processing. But what happens if we are working with legacy code? Probably we are not going to have those technical enablers, so it is a good reason to modify multiple aggregates in one transaction. The third good reason is global transaction policies. Let's imagine that there are some policies in the company that forces you to use global transactions and not let you use messaging or batching frameworks. In this scenario, you have a good reason to break the rules. The last good reason is query performance. There are scenarios where it's better to have a reference to an aggregate using the entire object instead of just the ID reference. This could be used to reduce repository query performance issues. With this, we finish with aggregates pattern. If you feel that is too much information about aggregates, take your time and revisit the videos. The aggregates is maybe the most important pattern.